Okay, so now we want to put it all together. What happens if we have both a change in the amplitude and in the period? Well, we're going to go through a laundry list of material and we'll just find all of these values and use them to help us come up with a table of values that we're going to use to graph or get a sketch of our function. All right, so first things first, anytime we have a function of the form y equals a sine of bx or y equals a cosine of bx, we find two things. The amplitude, which is the absolute value of the number in front of our sine or cosine function, and the period, which is found by finding 2 pi over b. And in addition to the period, again, I always like to stress that we are going to get key points that always occur at 1/4 of the period apart from each other. So key points are always found by taking 1/4 and multiplying that times the period of the function. All right, so we're going to keep that in mind as we go through our first expression right over here. Our equation is y equals 2/3 sine of 4x, and we would just want to put all this together to get a nice picture of this graph as far as the key points and everything else goes. All right, amplitude. Amplitude is found by taking the absolute value of the number a that's multiplied in front of our sine or cosine function. So in this case, that's the number 2/3. Period. The period of this function is going to equal 2 pi divided by b. Well, in this case, 2 pi over 4. That reduces to pi over 2. So pi over 2 is the increment that we're going to be dealing with. But we also want to get how far apart our key points are within one cycle of the graph. So we're going to find that by taking 1/4 and multiplying that times the period, pi over 2, and we're going to find that each of our key points will be pi over 8 apart from one another. So when we're making up our table, we're going to give increments of pi over 8. So let's look at this. The amplitude we so far have is 2/3. The period is pi over 2. All right, so we need a little table right here, so I'm going to draw a table. I'm going to get my x and y separated out right here. And the way I'm going to do that is I'm going to put in my values of x and my values of y, and I can use, since this is sine, I can use my sine template as a way of dealing with that. And if you remember the sine template, that was the one that included all of our key points starting at 0 and ending at our period of pi over 2. We add increments of pi over 8. Right, so we're going to add pi over 8 until we get to our complete set of key points, pardon me. So 0, pi over 8 is the first key point right here. We add pi over 8 again. Now, if it helps you, I'll do this on the side. 0, 1 pi over 8. We're adding increments of pi over 8, so we're going to have 2 pi over 8 as the next one. We're going to have 3 pi over 8 as the next one after that. Then we're going to have 4 pi over 8. So if we're looking at each of our values, we should, of course, reduce each of them. 2 pi over 8 reduces to pi over 4. That's our next key point. By adding the increment of pi over 8 again, 3 pi over 8 is our next key point. Since 3 and 8 don't reduce, we leave it in that form. 4 pi over 8 does reduce, and that becomes pi over 2. And since that's equal to our period, we're done finding key points. We have 1, 2, 3, 4, 5 total key points, which is what we should have. We're dealing with a sine function, so the y values always start at 0. But then we typically go 1 times 2 pi over 3, so we're going to have 2/3 here, so we're going to have 2/3 at the top of our expression. We're going to go back down to 0 at the next key point. We're going to multiply by -1, so we're going to get -2/3 as our next key point, and then we're going to go back to 0. Again, the reason that I know these ones is that if I remember what I had for the natural function, right? We had x and y values that went like this before we changed any of the domain or range, right? Our y values went 0, 1, 0, negative 1, and 0. And for sine, we had each of our key points within the natural period, right? So if I said y equals sine of x, I would have remembered to write it this way. But remember, we've changed the period, so we have pi over 2 is the period, right? We could fit 4 full periods within 2 pi radians here. And our y values, 0, 1, 0, negative 1, and 0, for the graph of y equals sine of x, looks like this, but we take each of these y values and multiply them by 2/3. So 0, 2/3, 0, negative 2/3, and 0. The only thing that remains is the plot. The plot of our graph, well, will look just exactly like every other sine of x graph that we've ever made in the past. The only difference right here is that our values will be slightly different looking right here based on our key points. So what will we do? Well, let's make one full period here. So we're going to start at 0. We're going to have pi over 8. That's our first key point. We're going to have pi over 4 as our next key point. We're going to have 3 pi over 8 as our next key point after that. And we're going to have pi over 2 as our last key point within one full cycle of the graph. We're going to go as high as 2/3 and as low as negative 2/3. So when we graph our function, we're going to say 0, 0, pi over 8, 2/3, pi over 4, 0, 3 pi over 8, negative 2/3, pi over 2, back to 0. So here's one cycle of that function, more or less. If we wish to continue the cycle, we would just simply keep on repeating every increment right here until we had the graph just repeated endlessly. So here's another piece of the cycle of our graph, more or less. Again, if we're just graphing, this is what it might look like. So this is our graph. Our domain, all real numbers. Our range this time goes from negative 2/3 in the y direction to positive 2/3. All right, one last example to come.